Okay, we're started. Okay, so for this, I'm not making you guys do questions 5 and 6. So we're going to do questions 1, 2, 3, and 4. Ready? So can someone raise their hand and tell me how we factor 81? We're making the factor tree, Mario?
Okay, actually, 81 is a perfect square.
And what is the perfect square with?
9.
9. So we have 9 and 9. You can do what Mario did. You circle them and you know that's a perfect square. P.S. So our answer here is going to be 9. If it does no longer have anything inside the radical, we drop the radical. We don't care about it anymore. Niqua? So Niqua's going to do number 2. Over here we see that we have 49. How does 49 factor, Niqua? 7 times 7. Once again, this is a perfect square. We circle our buddies. They make it out. 7 is our answer. For question number 3, we have to combine our like terms before we get started. Who would like to do that one? Reggie?
So we're going to do parentheses first.
Mm-hmm.
So negative 3 to the power of 2.
Which will give you what value?
Negative 9.
It's going to be a positive 9 because 2 negatives. So positive 9 and?
Positive 9 plus 12. 16.
Plus 16. Perfect. Then we combine our like terms inside. So 16 plus 9?
25.
25. And then how does 25 factor?
5 times 5.
5 times 5. That has a buddy. It comes out. Our answer is 5.
Good.
We also have our number 4. Anybody ready to do number 4? Mario again?
No.
Raya, you want to?
Yeah.
Okay, Raya, you ready?
Okay, we do 5. 5 squared is 25.
5 squared is 25, yes.
Plus 4
4. And then we combine our like terms.
is 29.
29.
Somebody has to go on this chapter.
Thank you. And then with 29, do we have any factors of 29? No? So what do we do with it? And we see that our answer is going to be that square root of 29. Okay, so we are going to move on to our vocab portion. Let's see if I can figure out how to turn the slide. Oh, man. I have no idea. Oh, that was all great while it lasted. I don't know how to change the slide. Oh, there we go. Okay, so we're here, and today's lesson's over 4.4, the Pythagorean Theorem and the distance formula. We have the objective, which is going to be to find the lengths of the sides of a triangle and the distance between the points. So you're writing that down. I don't have an objective part written for you, so you are going to write it yourself at the top of your papers. Ready to get going? Need another second?
Yes, ma'am.
Okay. So we have vocab here. I'm going to highlight your vocab words. You do not need to write the Pythagorean Theorem portion because I have that on another slide. So this portion you do not have to write, but the points I want are in a right triangle. The sides that form a right angle are called the legs. We also have a second vocab word in that same portion. Let's try this color over here. And we see that our color over here is going to be, let's do green. And we have the hypotenuse, and that's the side opposite of the right angle. I'm going to draw a picture that goes with it. So these are your 2 vocab words. One is in yellow and one is in green. Our third one is this distance formula at the bottom. So this would go on your vocab sheets. Do you guys need more vocab sheets?
Yes, ma'am.
Okay, Mario, would you mind handing them out?
Yes, ma'am.
Oh, well, I'll say you're here, but you have a...
She fine.
Okay, so the other thing I would like to draw is a picture that explains this. So on your page or on your main note sheet, let's draw a right triangle. Ooh, I'll erase the part I drew extra. And then we're going to write here, leg. We have a leg down here. We have a right angle. And the side that is directly across from that right angle is that hypotenuse. Yes, Jeremy?
Where are we supposed to be drawing this at?
You can either draw it on your notes with those two vocab words,
Like that?
or you can put it on your actual notes. Yep, or on the vocab sheet.
Oh, alright.
So this is your hypotenuse. Remember, that is directly across from that right angle. Do you guys need another second on this picture? Okay, I'm going to switch the slide. You good, Raya? Okay, so we have our example here, and this is another definition or the definition of Pythagorean theorem. So on your guided notes, you're going to write your Pythagorean theorem there. I'm going to draw again a picture using symbols for you to see it. So if you'd had a right triangle, we have A, we have B, and C is your hypotenuse. So here we have C squared equals A squared plus B squared. Yes, Mario?
I would like to set us up for number one.
You'd like to set us up for number one? So real quick, if I modified our Pythagorean theorem just to solve for our hypotenuse, what would that formula be?
A squared plus B squared equals C squared.
A squared plus B squared, and we want it just to be C.
Oh,
So-
equals C.
So we're going to square root both sides. So we know that C equals the square root of A squared plus B squared. I know it's a little high on my screen, guys. Can you see that okay?
Yes.
Okay. So Mario's ready to set us up on problem number one.
Okay, so 10 squared plus 24 squared equals C.
Equals C. What is 10 squared?
100.
We have 100. What's 24 squared? Anybody?
1 second, please.
Yep, you're welcome to use a calculator on this section, guys. So a nice reminder, if you need it, you're welcome to use it here.
It's 576.
576. Okay, equals, I dropped that squared, equals C squared. So we combine our like terms, which are those constant terms. So we end up with 676 equals C squared. We want to get C, so we're going to square root both sides. What is the square root of 676? Is it a perfect square? That's a good question. Is it? It is? What is it? So if you have a calculator, you put 676, square root it.
Can I use my phone? My calculator?
Somebody put that photo man scan it really quick.
Do 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 do. Do 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 do. Do 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 do.
It's 26.
It is 26. Dion is correct.
C equals 2.
I didn't hear you guys at all, so if you actually just say it, I really didn't hear you.
26.
26 is the correct answer. Yep. And so now we want to set up question number 2. I know Mario's all about this. Anybody else? Raya? 7 squared plus 7 squared squared. Yep. And so what's 7 squared? 49 plus 49. C squared. We're going to combine those terms. 49 plus 49 is 98. We want to square root both sides because we want to just find C. So square root both sides. We're going to do a factor tree. So what are our factors of 98? Factors of 98? 7. How many times does 7 go into 98?
14. 7 times 14 is 98.
7 times 14. So, ooh. What'd you say, Nikwa? 7 and 2. What has buddies? 7 has a buddy, so it makes it out. So C is going to equal 7. What doesn't have a buddy stays locked up. Square root of 2. Exactly right, Nikwa. Okay, again, we are solving for that C. So can someone else set this up? Yep. 9 squared plus 14 squared equals C squared. What's 9 squared? 81. Nikwa, what's your question? As long as your hypotenuse is what it's equal to, it does not matter which one was your A and which one was your B. So, what's 14 squared? 196. 196 plus 81. What value do we get? 277. Do we have any factors that we know of 277? So we're going to square root both sides. We actually find that we have no factors of 277. It's going to be a prime number. So C is going to equal the square root of 277. Again, if on a test, since not everybody has a calculator, I would not pick a number this big for you to try to figure out factors of 277. Do you have any questions before we switch the slide? You do? Okay, just one moment. Yep. Nikwa?
Did you ever figure out how to save these?
That's what we're working on right now. I think I have to be able to record it to save it. So that's our goal. I worked on it all last night. Ready, Dan? Okay. Okay. Our next one, we notice that we now have 4 examples where we have the hypotenuse. So we have the C square, or the C value, to square. So now we are solving for either one of the legs. So we're going to set that back up using that Pythagorean theorem. Again, our Pythagorean theorem is what?
A squared plus B squared equals C squared.
Equals C squared. Okay, so we're going to set up our first one. Mario, you ready?
Yes, sir.
Okay, what's the first one? How do we set it up?
11 squared
11 squared,
plus B squared
B squared,
equals 23.
23 squared.
Yes.
What is 11 squared?
121.
121
Yes.
plus B squared. What is 23 squared?
529.
529. You did that very quickly. 520. Okay, we're going to subtract our 121 to the other side because we want our like terms to be together. So 121, we're subtracting it from both sides. We get B squared equals what?
408.
408. Okay, now we want to solve for B, so we're going to square root both sides. Mario, you ready?
Yes. Yes.
What are our factors of 408?
2.
2. How many times does 2 go into it?
8 can go in it.
12 can go into 34 times.
So let's start with what Mario started with because he started there. There's more than one way to do it, so you guys can continue your way.
2 and 204.
204.
Yes.
Okay, what else goes into 204?
I ain't answering that. You could beat on your way.
204. 6.
How many times does 6 go into 204?
34.
34, do you guys agree?
Yeah.
Okay, and then what about 6? I'm getting really low. Do you guys mind if I draw it over here?
No, that's alright.
6, 34. So 6 is going to be 3 and 2. What are our factors of 34? So it's even. So if it's even, what do we know goes into it? 2. How many times does 2 go into it?
17.
17. 17 is a prime number. We can't go any further. So things that have buddies. I'm going to highlight them because I have it all over the place, so it's going to be hard to circle. So I have... Interesting. Okay. We're going to highlight here. We have a buddy with the 2 and a 2. What doesn't have buddies? A 2, a 3, and a 17. What doesn't have buddies gets multiplied together. When we multiply those together, what do we get? 102. Yep. So your answer for B equals square root of, B equals 2 times the square root of 102. I wrote pretty big in the middle there. I'm going to box this in. So I'm going to choose another color so you can see that I'm done with that portion. And I will work within my range for the rest of them. So I'm going to choose blue, unless you guys have a problem with seeing blue. And we're going to set up question number 5. Nicola, you want to set up question number 5? You had your hand up for the last one. So let's just set it up.
Okay, is it
8.4 squared
plus a squared
plus a squared
equals 11.9 squared?
11.9 squared. Okay, with decimal points, I do not expect you to know the squares of these, right? They are not whole numbers. So you are welcome to use your calculator here to find those values.
I know what 8.4 squared.
What is 8.4 squared?
70.56 plus 70.6 if you round.
I want the full thing, so you're right. 70.56
Yeah.
plus a squared equals, what's 11.9 squared?
It's 141.61.
141 point what?
61.
61, thank you. Again, we're combining like terms. We're going to subtract over that 70.56. We end up with a squared equals, what is,
1.05.
say it one more time, please.
71.05.
Do you guys agree?
Yes.
Got one no, one yes. Anybody else? Do you agree or disagree? I agree with Jeremy. So our last step is to solve for a. So we're going to square root both sides. So I end up with a equals, what's the square root of 71.05? Again, I would expect you to use a calculator on this. You wouldn't just know this.
You want this?
8.4?
No, just do the first decimal place.
8.4.
Yep, it's just going to be that 8.4. And Jeremy asked an important question about rounding. When it comes to your final answer, you could round to 1 decimal point because our other ones were just 1 decimal point. So thank you for asking that. And then we have question number 6. Question 6. If I write in orange, will you guys be able to see it?
Yeah,
Can you see that okay?
for sure.
Okay, so who would like to set up question number 6? Reggie?
Okay, so we're gonna do 26 squared plus
So remember that's our hypotenuse, so that's that C. So 26 squared equals,
equals
you're fine, you keep going.
equals a squared
A squared,
plus 24 squared.
perfect, thank you very much. Okay, and now we are going to square 26. What is the square of 26? 676. What is the square of 24?
576.
576. Yes, Nikwa?
Why would we say anything about the money?
Why don't we say anything about which one?
The money with the right angle.
So all of these are going to be right angles, so that's what allows us to use the Pythagorean theorem. So we're only interested in the sides of the right triangles. Okay, so these are convenient numbers. I'm going to subtract that 576 to the other side.
That's 100.
And yep, you're right. It's going to be 100. 576. I get 100 equals a squared. We want to find out the value of a, so we're going to apply a square root to both sides. I get, what's the square root of 100? It's 10. A equals 10. Do you guys have any questions on these three? Any questions on these three? Do you need another second to write them down?
Yeah.
Okay, so if you're still writing them down, I'm going to give you a second. I'm skipping this slide for today. We're going to come back to it tomorrow. And we're going to talk about the distance formula. We had the distance formula in our definitions portion. You do not have a spot right now on your notes to write that in. Oh, you do. Okay, so I want you to rewrite the distance formula there. Can anybody remind me what the distance formula was in your notes previously we just got? Beginning of the hour. You ready?
If A, and then parentheses X, comma Y, and then B.
1 second. Let me view real quick. So yes, that is, you are correct. That is the distance formula, but I'm looking for this portion here. So Mario, you ready? So you were reading me the whole definition, and I appreciate that. You did a really nice job. But if I just want the formula, Mario, do you have just the formula?
Yes.
What's just the formula?
AB equals square root parentheses x squared minus, x2.
Yeah,
plus
x sub t-
x1
Yep.
parentheses squared plus y squared minus y1 squared, parentheses.
Correct. So guys, I'd like you to re-add this to your page. We noticed that it's distance, and when we talked about distance previously, that we know that distance of segment AB, or the length of AB, we don't put a line over it. We know that we're talking about distance because there's no line here. So notice again that we have x2 and y2, x1, y1. It does not matter which one is which. We just have to make sure that we are determining that beforehand. So you do not have this example. So what I'd like you to write down next to your formula is these points right here. So we can still find them. You do not need the graph. So just write down the points that we highlighted, and we're going to solve it. So I'd like to determine which one's going to be x1 and y1, x2 and y2. Mario?
x1 is -1, x2 is 4.
Okay.
Y1 is -2 and y1 is -2 and y2 is 2.
So this is just to help us for later, to make sure we aren't confusing which ones we determined. And now we're just going to substitute them into our formula. So we get AB equals, is it AB?
Yes.
What's our points names?
K,
K and L. Sorry about that. So KL equals the square root of x2, which is what value? 4 minus x1, which is quantity squared, plus y2, just 2, minus y1, which is quantity squared. Are you guys okay with how our formula is set up? Okay, we know that when we have two negatives, it turns into what? A positive. So we have 4 minus negative 1, which is going to be 4 plus 1. So that's going to give me 5 squared, plus 2 minus negative 2, which is 2 plus 2.
Yeah.
It's going to be that 4 again. So we're going to have 4 squared. Now we're going to perform these operations. So 5 squared is 25. And 4 squared is 16. Thank you. 16 plus 25. 41. Is there anything that's going into 41? We see that nothing is going to go into 41, so our answer is just going to be the square root of 41. You're fine. Do you guys have any questions on how that one was set up before we do our next examples?
Hold on.
Okay, so I'm going to go on to the next slide. We have 3 more problems set up much like the last one. So the first thing I normally do is I define my points. We see them in our picture, but I like to rewrite them so that I can see what we have. So we have B is negative 2, 4. And we have A, which is 3, negative 1. We're going to decide which one's going to be A and which one's going to be B. Or nope, we know which one's A and which one's B. We're going to decide which one's going to be X1 and X2. So X1, Mario?
Negative 2.
So we let X1 be negative 2.
X2. I mean X1.
Oh,
Yeah,
whoopsies.
backwards.
Sorry.
No sadness.
Thank you. So X1, and what's over here?
X2 is 3.
And then what's our Y1? It has to be the one with the 4, yep, because it's what's with X1. And which one's Y2? Negative 1. Okay, so we have defined these, and now we're just going to use that same formula.
Excuse me. You have an error.
Oh, thanks, Mario.
Yeah, you are.
I heard what I wanted to hear, and I wrote what I wanted to do. Sorry about that. Okay, so we are going to rewrite that formula. So we have that AB equals the square root of
AB.
Parentheses X2
X2.
minus X1.
And then,
Jeremy taking over.
yeah, would it be 4?
Hold on, wait. We're just doing the general formula.
Oh, just the general formula.
Yep.
Then it'll be y2 minus y1. I thought we was doing my
Whew.
thing. You need
It went away. Sad. Okay, let's try it again. Ready?
Yeah.
Okay, so we have AB equals the square root of
X2 minus X1 and then plus y2 minus y1.
I'm sorry.
Okay, so now we're just going to substitute in. We just wrote all that out, and unfortunately I erased it. So you can keep what you had, and you can start substituting in while I rewrite what I had. Please feel free to work independently at this moment until we have it back to where we should. Okay. So my distance formula, I have AB equals the square root of, and then we have X2, which is
3 squared,
3 minus
negative
negative 2, quantity squared, plus
2,
negative 1,
minus 4 squared.
4 quantity squared. Yep. Okay, so over here we have 3 minus negative 2, which gives me 2 negatives. Change that to be a.
Positive.
Yep, so 3 minus negative 2 gives me 3 plus
2, and that's going to equal 5 squared, right?
Yep, we have 5 squared. And then negative 1 minus 4.
Wouldn't it be
also-
3? 3?
No, wouldn't it be 5 squared?
It's going to be,
Negative, positive.
so we have 2 negatives.
It's negative now.
So you take away 4 more from a negative 1. So as we move on, it's going to give us a negative 5.
Oh, negative 5. I'm sorry.
So we have a negative 5, and that's squared. So 5 squared is what value?
25.
And negative 5 squared is?
Negative 25?
No, it's actually 25.
25 because the times it by the negative and negative, that's going to be a positive.
There you go, Tanae.
So 25 to 25, and that's going to be 50, right?
So that's going to be square root of 50. Ryan, were you asking a question, hon? So it's going to be negative because we still have 2 signs here. So both of these are negative. So let's be nice to each other. And so we have that because it's negative 1 minus 4. So we're still going over. Nothing's positive. So 2 negatives do indeed make a positive when you square negative 5. So negative 5 times negative 5. We have the square root of 50. 50 is something we can find the factors of.
5 and 10, right?
We can do 5 and 10. And what are your factors of 10?
25.
5 and 2. Things that have buddies? Things that don't have buddies?
Go inside.
2.
Stay inside, and that's going to be that 2. So our distance is 5 square root of 2. I'm going to switch colors as we go to our next one.
Purple. No. Pink. No.
I'll go with pink.
Let's go red. Oh, we just do red.
So here we have C and D. So we have point C. Ooh,
Why can't you use blue again?
we can go back to blue. I'll do it after this one.
Me and Blue got this.
Okay, and so then we're going to go and define these. So we want this to be x1. This is y1. And then over here we have x2, y2.
So,
We're going to use that same formula, but now we have CD. Okay, Jeremy and Mario's really done a great job answering all the questions and competing with each other. You're doing a nice job too. I'm saying we should let somebody else do it. So if anybody else wants to set it up other than the 2 that have been racing each other. Nicola, you ready?
What we doing first?
So we're creating that square root. And you want to sub in
It is the x1.
x2 minus x1. What's your x2 value?
Is it the whole? Oh, what's wrong with yellow? Oh, 5 minus
5 minus what value?
5 minus negative 2.
Negative 2, quantity squared, plus y2
5.
minus
5.
minus 5, quantity squared. Down here we end up with the square root of 5 minus negative 2. What is 5 minus negative 2? 7. So we have 7 squared. Plus 5 minus 5 is? So we have 0 squared. Over here we now have the square root of, what is? It's 49. 7 squared is 49. We know what about 7? It's a perfect square. And what is the value going to be? 7. We could have done this, since it is a straight line like this, we could have actually verified it, and we could actually count those out. So you see here, 1, 2, 3, 4, 5, 6, 7. So we see that we have 7 units that we traveled across here. Here, since it's not going to be directly in one dimension, not the way I want to say it, but we see that that's not going to occur, so we have to use that distance formula. Our last example, let's power through it so we can get done. And we have E equals negative 4, negative 2. And then we have F, which is 4, 2. Here we have x1, y1. We have x2, y2. We're going to go down here, and we have the distance of EF equals the square root Anybody ready to take it? Nikwa? So-
Negative 4, never mind. Maybe.
I'll take it.
So, Jeremy, you ready?
It'll be 4 minus negative 4 squared. And then it'll be 2 minus negative 2 squared.
Okay. So we have 4 minus negative 4, which is?
16.
16 squared.
So 4 plus 4 is
8. Oh.
8. So we have 8 squared plus 2 minus negative 2, which is the same thing as 2 plus 2.
4.
4 squared. 8 squared is
61.
64
Oh, 60.
plus 4 squared, which is?
16.
16.
Okay. And then we want to combine those like terms.
90, wait, no, 80. Wait,
So
70.
80.
80.
it's going to be 80.
Yeah.
We can create a factor tree. What do we have?
10 and 8.
8 and 10. 8 goes to
2 to 2. Or 4 and 2.
4 and 2.
Then 2 to 2.
We see here we have 2, 2, 2. Over here we have 2 and 10, or 2 and 5.
Yes.
Things that have buddies, 2s, 2s. 2 times 2 is?
4.
What doesn't have a buddy?
5.
5.
Thanks, guys.
You paused it.